Here's another recording from problems from section 3.3. In problem number 13, we're given that y is equal to the product x plus 1 times x squared plus 1. And essentially we're asked to do this problem two ways. One by using the product rule, and the other one by expanding and then doing finding the derivative two different ways, one by using the product rule and the other one by multiplying out first and then using other differentiation rules. Let's do the product rule first. If I take the derivative of both sides of the equation, the derivative of this thing, and we recognize the stuff that I'm taking the derivative of as a product is equal to the first element times the derivative with respect to x of the second element plus the second element times the derivative with respect to x of the first element. So continuing this on, I get x plus 1 times the derivative of x squared plus 1. Now I might write this very explicitly, or I could just say that that's going to equal 2x if I'm feeling very comfortable with my differentiation skills. Over here I could write this out explicitly in each step, but I think we can pretty much say that that's equal, the derivative of this is equal to 1. And now if I distribute the 2x through both terms, I get 2x squared plus 2x plus x squared plus 1. And then collecting the common terms, I get 3x squared plus 2x plus 1. Now that's again using the product rule. If instead I go over here and I use FOIL or distribution to expand this, I end up with x cubed, there's my first, outside is going to be an x, inside is going to be an x squared, and last is going to be a 1. So when I take the derivative of both sides, and I'm going to rearrange these in descending order now, descending powers, I get dy dx is equal to the derivative of the first term is 3x squared, the derivative of the second term is 2x, the derivative of the third term is 1, derivative of the constant term is 0. And you can see I get the same answer, and this shouldn't surprise us. The answer is not going to be contingent on which of the two methods that we use. Now you may say to yourself, well geez, the second method looks a lot simpler, a lot faster, and you would be right in saying that was true, but the other thing is there's going to be sometimes when simply expanding these terms are either not efficient or not an option. Okay,